our talk today. Our talk centres around the concepts of server-driven UI. Now, I'll just clarify. Oh, got a bit of feedback. Just clarify, this is not server-side rendering. I'm sure there's a lot of people in the audience that know a lot more about that than we do. What we're actually talking about is an architecture for native apps where we build the UI definitions up on the server and send it to the clients, which requires less client releases and less client updates. We're going to share our experience building our own one from scratch over the past 4 years. We've done this in Kotlin. It's been part story, part tech talk. We've got some insights, some architecture, and a load of dodgy AI-generated cartoons. Anybody here familiar with server-driven UI? No. Don't worry if you're not familiar. We'll go through it a bit in the talk. We'll give you an overview in a bit. Probably good to introduce ourselves at this point. So I'm Jimmy Ray.
My name's Harriet Taylor.
And we're both part of the native apps team at AutoTrader. Little overview of what our role entails. We look after the Android native mobile app, but we also run a lot of a gateway service and a few different back-end services. These are done in Java and Kotlin, mostly Kotlin now. We're trying to less and less Java as we go. Any Java devs about? Oh dear, we're less harsh on the Java jokes. I still love it, it's great. I was there. Kotlin now. There's iOS as well, but we don't look after that. There's other people in the team that are Swift experts. In our talk today, we'll start off with the intro, which is what we're in now. Then, as all good stories do, we'll start at the beginning, which will go over why we decided to move to server-driven UI, a bit about what it is, and a bit about the challenges we faced. Composing Composable, we'll go over what we built and how we built it. Some tech insights, which will give some deep dives into different things like how we handle versioning, the domain-specific language we wrote it in Kotlin to render the screens with, and a few other little bits. And then we'll have a retrospective over the past 4 years, followed by some questions if we've got time. You'll be glad to know the intro's now over, and I'll hand over to Harriet for the beginning.
So, to understand why we built our framework, it probably helps to understand who we are a little. And we're AutoTrader. So who's AutoTrader? We're the UK's biggest digital automotive marketplace. Now, a lot of people still think of AutoTrader as the classified ad magazine from back in the day, but we actually stopped printing magazines over a decade ago in about 2013. So what we actually are is a tech company with an entirely digital marketplace driven by masses of data. We released our first website back in 1996, and that was before Google even existed. No idea how people were finding the website. And now we get about 5 times more daily car searches in the UK than Google gets. So, like I mentioned, we're a technology and data company. We're the UK's largest automotive marketplace, and we're one of 2 tech companies in the FTSE 100. So our data is so strong, that it actually informs the ONS and government for its financial projections. We serve over 18 million car searches a day. We've got about 80 million consumer visits a month, and on our apps, we have 3 million unique users a month. The apps account for around 50% of traffic. So talking a bit about the AutoTrader culture and how we are in the office, there's about over 400 people in the product and tech team. And they're split into different teams working on different features. They own over 700 microservices, and we make over 200 releases to production a day. We also handle over 8 million API requests a day. It's a very fast-paced environment with a lot of change going on at any given time. So picturing the scale of this big operation and the amount of traffic that we get, let's have a little look at the domain of apps. So we've got 2 native apps clients. We've got Android and iOS. Android uses Java, like Jimmy mentioned, in Kotlin, and iOS uses Swift. But for those, we only have a small pool of developers. The web team is a lot bigger than the apps team. So everything needs to be written twice for both clients, and it needs to be tested twice. And once you've released an app, you can't make a user uninstall it. There's no rolling back. Like any changes must be right. And on top of this, we have to make any releases to the App Store, which that just adds time onto the release process as well. So going over this a bit more, we write the code twice. Then we have to do a heavy test and regression pass due to the nature of the code base and the fact that we can't roll it back or roll over. At the quickest, this can take a day alone. Then we have to release it to the stores, and that can take up to 72 hours. If the app isn't rejected for a daft reason, like it has before, when they couldn't see a button, for example, then we can stage a rollout over about 7 days. And after that, it can take our users up to 2 weeks just for the new client to be downloaded, and that's only for about 85% of them. Not everyone updates their apps. So that can total up to about a month for one release and for one change just to get it into the user's hands. So if you compare that to a server release where you code, test, and merge and straight into the user's hands, it's a lot different. It's a lot more time consuming. So taking all those pain points and slow releases, throw in a fast-paced environment with lots of products and changes, and you can start to see our predicament. So this left us with a huge backlog and a team that was just overburdened with work between two platforms. We were far behind web for many products and changes, and we couldn't even keep the Android and iOS products aligned. In fact, sometimes we'd come to features months or years after web had already completed it. So that meant we were always late to the party, and it meant that we had to change the way we worked. So we came up with a few possible solutions, and one thing we looked into was React Native. If you don't know what React Native is, it's a framework that allows cross-platform development using JavaScript, but that would mean that the team would need to learn a new language. And it would also mean that we'd have to recreate a lot of functionality and logic, and you know what, a complete rewrite of the apps would take a lot of time, so we decided against that approach. We looked into Flutter. If you don't know what Flutter is, it's an open source framework by Google, and it allows you to build multi-platform applications from one code base, but at the time it was pretty new. Not too many people used it, and it wasn't server-driven, which meant that for us, it kind of defeated the purpose of what we were trying to achieve, and we were trying to get more web devs involved. We were trying to create products faster, releases faster. So we decided against that. We also looked into web views. And web views are essentially just browser within the app. It's only practical for entire pages. It's hard to make them look and feel like a native app. Users can get lost navigating inside of them. It's hard to do the analytics and tracking in a web view, and our users deserve more than a website in an app shell, so we decided against using web views. So things changed a bit when some of our developers attended a conference in this very venue, DroidCon, back in 2019, and Spotify did a talk about how they were using server-driven UI and how it solved a lot of their problems by moving the UI to a back-end service. A lot of other big software companies at the time, like Airbnb, were also looking into using this type of service. So if we think about how a client-based UI works, which is how we were working at the time, if we just look at AutoTrader terms, we'd request a car advert up to the AutoTrader services, we'd get that car advert data back down, but then on both clients, we'd have to handle the business logic, the UI definitions, and render the UI. So we were doing the work twice on Android and iOS. It's great for showing static content, but it's just time consuming. Now, if we look at server-driven UI, it's a lot more flexible, right? We're making that request for the advert data up to our backend for front-end service, which will then get the data from the AutoTrader services, but then our backend for front-end will handle the business logic and build the UI definition, which will then send down to both app clients, where they will just parse this definition out and render the UI. So we're essentially moving that work from the client up to a service that's going to share them. It's much more like how a website's done, and it's simplified the process and speeding it up. To us, it was a no-brainer to go for this approach. So just a few mentions of how it fixes the problem. It means we've got consistent UX across both platforms. So iOS and Android are a lot more aligned now because they're operating from one source of truth. The dynamic changes to the UI without requiring updates are a big, big help as well. Streamlined release process. I went through how tedious the release process on apps can be. So without needing a release for all changes, we still need to make releases, but we can deploy updates faster, and that helps us respond to market demands a lot more quicker than we could. It also helps us with A/B testing. We get faster A/B testing by allowing server-side variations of the UI components. And it's easier for personalized content delivery based on like user profiles and contextual data. A quick example of this is, to begin with, we had a dabble with a system building the app's home screen in 2019. That was server-driven, but it was only one screen and not a framework, and it was very, very limited in customization. But you might be thinking, how can a small team with a huge backlog, like we mentioned, build a huge framework like this? So I'm going to hand over to Jimmy to explain.
Yeah, so we knew what we wanted. We wanted to build a server-driven UI, and we wanted to build our own. It was time to tackle probably the hardest question. How to name the thing. No surprises here, said it a billion times in the talk already. We called it Composable. At the time, we were working with design systems, we were looking at different UI kits for the native platforms, we were looking at Swift UI on iOS and Jetpack Compose on Android. We liked the idea that you could compose a screen of different components. That sounded really cool. And as an Android developer, getting the Android sounding name was really exciting because it was a win for Team Android. Until you come to talks like this, and you've got to say things like, we compose our composable components using Jetpack Compose composables. Or other code reviews where you've got to say, do you mean Jetpack Compose or composable?
Tongue twister.
Yeah. Naming aside, we already had a design system at AutoTrader, so that gave us a definition of what components we could send to the client. So that was a really good starting point. That was the first requirement of our system. We had a few other requirements, so we had to keep building business products. We had a massive backlog, we're a small team, we can't stop. And we prefer not to rewrite the apps because we want to get some value out quickly, which meant we had to support the old services and clients, ideally do hybrid screens, so if we wanted new content in an old screen, we wouldn't have to rewrite the screens. Which meant native rendering, so we wanted everything to be rendered natively, so the app users still get that good native experience and it's seamless. We needed to open the apps to other teams to get other people building products on the apps, but we also worried about maintaining the app quality. Non-app developers are not going to be experienced in giving the app experience as we are. But that's fine, we can look after that. Language and tech-wise, we decided to go for Kotlin with JSON for the data payloads. Number of reasons for this. It was already in use for Android. We've got interoperability with Java, so we can actually build it. We're a big Java shop at AutoTrader. We do a lot of Java services. We can use Kotlin with those Java services without much problem. So we can do things like build a Spring Boot server and use Gradle, so we don't have to have a new technology for the app processes. And it's less of a barrier for the other Java devs, and the whole idea is getting more of the business involved in making apps, so why not make it easier for them? It's object-orientated, functional and type-safe, so we get some cool functional stuff, like making a domain-specific language, or DSL, which we'll talk about in a bit. And we get things like Kotlin multi-platform, so we can do Java, but also JavaScript and a number of other things with it. So, question arose, where do we start? What do we ship first? We had some ideas. In fact, we had a whole pile of ideas. We were getting really long conversations. We were thinking, what if we need this in the future? What if we need that in the future? We were obsessed about everything being perfect from the first release, that it was stopping us doing everything. So, we decided to scale it back. Do the most agile thing I've ever done in my career and just build what we only need at the time. And what we needed at the time could be specified by the products we were making. So, if we built the system as we built new products, then we could have both a system and deliver products at the same time. So, with that all set in motion, decided to set sail. Our old architecture, we had the app clients, they would talk to a gateway service, which talked to a legacy app backend. So we already had a kind of backend for front end, which would convert the auto-traded data to something the apps read better, but it wasn't server-driven UI. We took that and we kept the back end. We added in a new back end for front end, which does our server-driven UI and has all the logic and business logic for our pages. And that's the only access point for Composable. That's the only thing that renders our server-driven UI, single source of truth for the lot. The legacy backend can still get the new Composable content by talking to the new backend for front end. So we've got the ability to have old responses with new content. Within that backend for front end, as you saw in the diagram before, that's got the business logic and the UI definitions. It's got our server-driven UI library in the background, and the app clients each individually have a client library. So we still have to do client releases. We've not got away from that. But we can render a whole lot of stuff from the server. All of this content is now shown natively. If you're an Android user, this is the Android Developer Tools Layout Inspector that proves that your app is rendering natively. All those little boxes are native. If it was a web view, it'd just be one big box. If we want to play with it and see which apps are actually rendering natively or not, it's in the Developer Tools. Under Developer Options, show layout bounds. It's fun to play with. So, first things first, we had our first iteration. We built a couple of buttons and links, the ability to show an image and the ability to show some text and headings. We also added a spacer in there as well, but you can't see that because it's a space. That allowed us to build some simple screens like this. Small start. From that start, we then added more things. We added stricter versioning handling, really thought about that. That was one of the first things that we really wanted to get in and get right. We added a Kotlin DSL, and we'll go through both of these later in the Tech Insights. So that allowed us to render the pages from the server in a nice format. I'll have that slide later as well, I think. We added support for dynamic UI and forms and input, which is also in the Tech Insights. Better layout handling, so we actually only originally started with everything draws in a vertical list. So we added horizontal and richer vertical list handling, richer text, more and more nice, cool, interesting looking components, things you can interact with, until we're actually at the point where we've got the majority of the design system, and we're still adding more things, but we're not adding as much as we needed to before. Like, we can actually do loads and loads and loads of pages without a single app developer touching the screen. Here, every single blue section is a composable server-driven UI section. The white sections are the old native code. Now, if it wasn't painted blue, you wouldn't notice the difference. And that's exactly what we went for. It's not blue in the real app. I'll show you now. So we added analytics. We can send tracking and stuff back from the server now, and if we need to change tracks, we can do that from the back end. Test utilities, like just checking if components are in pages, some nice UI tests there. A service launcher, as you'd seen, our back-end estate's grown. We've actually got the ability to start any service we want in a Docker container straight from a little app in your Mac. And that will interact with anything you're running locally as well. So if you only want to run one thing locally, that works fine. We've started moving stuff more to Kotlin multi-platform. We've got shared logic across the clients. And we've got a component browser. So this is great for design and testing. We can browse all the different components that we've got within the system. It's also written in Composable, so that's quite fun to do. And we've ended up in a reasonable place from it. Most new features are now built in Composable. We've got 30 plus non-app devs have contributed. About 40, 50,000 lines of code now have been written by people that aren't app developers for our apps. 5 different app teams are now building their products on apps, even though they're not app teams. And a backlog is significantly smaller. In fact, we're almost feature aligned on a lot of things now. So it's over 4 years. It's had a massive impact. So with that, we're going to jump onto the tech insights section. I'll hand back to Harriet for the first one.
So I'm going to talk a bit about versioning, which we briefly mentioned before, and how we approach this. So our approach of incremental development meant that we needed to have a strong versioning strategy. We wanted the ability to change most of the API as we developed it. So new components are built, old components change, new functionalities are added, old updated. If a client makes a request to an endpoint, we only want them to get what they can render. But our clients still have to go through the release process, and we know users might not update them. They might not be able to update the client if they're on an old OS or an old phone. That means we have to support multiple client versions at once with different versionings. Thankfully, the apps keep clean, and we don't need to worry about versioning on the client. It just supports the one API version. It understands, and the responsibility of versioning lies on the server. So the server makes sure that the clients only get the responses that they can support. So the core solution for adding new functionality and components is pretty simple. Each endpoint has a minimum version of the API it supports. A client the same API version hits it, we know it can render the UI, so it gets the UI back. A client with a higher API version can support that UI too, so we send the UI back. A client with a lower API version might not be able to display some of the components, we send back an error. This is all done at controller level when we try to render the page that's been requested. So what happens when we change existing components or functionality? The clients can still show the UI, but they might just expect a different response structure. I'm sure many of you know the pain of trying to change a data type in JSON payload from maybe a string to an int. We'll have a malformed response. Here we've got an example of our original text structure in 1.3 versus 1.9. Like, they're displaying similar things, but the payload's completely different. So this is where we add another layer of versioning at a component level. Each component's got its own render function that takes in the version. It then renders its own JSON based on the client version. So in our example for 1.9, we change the payload for text. A 1.0 and 1.3 client both get the original payload. A 1.9 gets the 1.9 version and nothing breaks. And this pattern can be repeated for almost all parts of a response. So each object is responsible for its own rendering depending on the version. We can support different UI for different versions also. So in this example, we added features, meaning we could add the banner and bullets on newer clients. So this is our guaranteed part exchange on version 1.3 and then version 1.4 and higher. And this now brings us to the DSL, which Jimmy's going to explain a bit more in depth.
Yeah, so going over that versioning, you can see it's probably get really confusing if you're trying to handle that yourself. So this is where the DSL comes in. I mentioned it before, it's a domain-specific language. Think like HTML for web, SQL for databases. It's a language that handles a specific function that you want to do, or a subset of a language. So who here likes writing pure JSON and handling different versioning? No? I shouldn't have my hand up here, for I hate it. That's what our DSL does. It handles a lot of that. If we jump back to the page that I showed earlier, over on that screen. Here's the DSL definition of it. We've got, you can see we've done a page, it's got a tracking identifier and a title in it, a few spaces in there, got an image, header, some bullet points and text. Reasonably easy to read, reasonably easy to do. We've actually changed this now. You don't need all the spaces. We've got better layout handling, but it shows a bit of the power of the DSL that this is the first page we've built and we've hardly had to change anything of it and it still works. And the way it works is because it enforces a lot of things. So it enforces the styles and the type safety, and it abstracts away from that API, that JSON payload that's a real nightmare to try and change and a real nightmare to try and write. So as we mentioned with the text earlier, you can see here on the actual definition in the DSL, it's all done with tokens. Whereas in the JSON payload, we're sending over raw values like 0.9, and the text's actually a attributed text string. It's not even the same format it is in the DSL. The size is just a number, the colors hex code. So originally we actually tried to send tokens down for all these and have that match on the clients, and we realized that every time we wanted to change a color, we had to do a new client release. The DSL prevents that. It also allows a lot of things with versioning that we mentioned earlier, where different clients can handle different components. So there's this notion of a feature set here. That feature set is our definition of what a given client can handle. So if you're working in feature set 1.5, you'll only get stuff that you can actually render to that client, which prevents developers accidentally putting something in the wrong place. And the beautiful thing about it as well is it's all explorable through IntelliJ. So with the auto hints in there, we're on 1.3 here. You can see we've got a load of different options for what you can actually render in that page. If you're on a 1.0 client or a 1.0 endpoint, you probably get 5 things. If you're on a 1.12 endpoint, then you get a whole ton of stuff. Now, I'd love to go into more on the DSL and how it's made, and believe me, I tried to write it up and I couldn't. So here's a slide with people that are far better explaining how to make one than I am. The last slide on there is actually our own Paul Samuels from the app team saying about how he made a DSL for UI testing in Maestro. The QR code will take you to all the links that are in this talk, as well as the engineering blog. I'll have the QR code on later as well, so look at that. Then, with the DSL, we'll move on to forms and dynamic QI. So, when we originally did it, we've got this great structure. We can request pages, we can send back pages, do that all day. It's great for doing static content, but there's no way to interact on the client or do anything dynamically. You request a page and you get a page, and that's it. And it wasn't long until the business had a requirement that there was a new project that needed a form. So we had to do validation, we had to do UI showing and hiding, we had to send up the responses from the user to the server. And that meant that we had to take our own old structure and we needed something that would send logic and state down to the clients for them to execute, and then some way to send that state back up from the clients. So, time to get thinking again. We had to think, we came up with some ideas. Most of the ideas were rubbish, and we'd found Redux in the research, so we just basically made our own version of that. When we looked into Redux, the way this works is the UI can subscribe to a set of key value pairs within what they call the store, and it can dispatch actions. So it can't actually modify the data within the store, it can only dispatch actions. And all of this is done with key value pairs, which is absolutely perfect for our situation where we needed to send and handle this with JSON. So we skipped, there was a reducers section in there. Can't remember what that means now because we skipped it. We built our store. Our consumer is each individual UI component that goes on the screen. That can execute actions on the store, and the store emits its state changes and the UI updates. Quickly go through that again. Execute actions, state change. So if we get a screen like this with a little edit age page, we could have the enter age set to set age when it changes, and it could observe the age field. So obviously, as you're entering text, you may want to pre-populate the text or modify it in some way. And then this enter age text message could observe that. Now, if I input my age, 21, into that text field, I'll set the age on the store. Because it's done through an action, it can update the age field, but it can also do other things. It can do anything you want. I mean, we don't know what the actions do. It's just an action, and we're calling it. So it could enter update the age message as well. That sends back to the UI. The UI updates with my correct age of 21. Now, because it's just a string-based action, we don't just have to have it bound to one type of input. I mean, a submit button, we made those buttons in version 1. We can still bind the same actions to any of those buttons. So on click, validates the age, and then updates. Harriet, have you been messing around with these? Cheers. And we get the new updated message. Little deep dive into that black box. In that black box, we've got our logic and actions. These are shared between different stores, so there may be different pages that want the same functionality. We can share the logic, because that doesn't matter. It's the state that matters for that specific page. And this is done in JavaScript. We actually originally did it in some really cool JSON language that I'd invented, but everybody else didn't think it was cool, so JavaScript was miles better. Then we've got the state, which is done per store, it's persisted, and we can send that up on the requests. So think of it like a cookie. That's the easiest way I describe it. And all of this is now done using Kotlin multi-platform, and that's how we bind it to our DSL. So we wanted to make sure that if anybody's making a page or making a store or working with any of this stuff, there's very little room for error. You don't have to manually go type in strings and keys and pairs and stuff everywhere. And if we look, this is how it's generated. This is some of the logic that would drive, say, that age store. It's all done in Kotlin. We've got some annotations that will generate the JavaScript code for us and allow us to interact with our DSL. But the rest of it's just basic Kotlin logic. We can send anything we want down to the clients, really, and we can just build it up that way. When you want to build it into some of the UI on the front end, everything is tightly coupled. So we send in a store, the age example store. We've got the age property, the age message property that's done on the text source there. When the button is tapped, it calls the submit button tapped action. And that in the back end, when it converts it to JSON, just links the strings up. So it links the names of the actions and the names of the properties. But because we've done it in Kotlin with the Kotlin multi-platform, it means that it's all tightly coupled and defined on the server. So there's very, very little room for error. We've not actually had any of the stores break yet, which is brilliant. And that's given us a way to send my store with its logic and state down to the client. That logic can be executed and the state can be updated and stored, and we can handle forms, dynamic UI, and loads of other cool stuff. We're still finding more and more possibilities with that as we go. So, tech insights over. We've got a quick retrospective over the past 4 years.
So we're going to switch it up a little bit, and the format now is retro. I don't know if everyone's done a retro, I'm assuming we have done in the room. But the formats went well, to improve, and actions. And we're going to do it with little post-it notes. So we're going to start with the good column and what went well. So the first ticket that we've got is not trying to do everything at once. So wanting to get it right the first time made it hard for us to do anything. We just couldn't get the ball rolling. But with our versioning and sort of pushing decisions down the line, that made it so much more easier, and it gave us the ability to spike and try and change plans after implementation. So once we let go of trying to be perfect, it was a lot quicker and easier to make composable. Do you want to talk about this one, Jimmy?
Yeah, so a number of the core concepts that we had kept quite simple. It didn't really go over it much in the presentation, but components, the core concept of that is if you have a UI component, it's responsible only for itself and its children. They don't know about each other. If they go in any UI, they should work. And it was concepts like that that's really allowed the system to evolve. It's let other people contribute. It's kept things straight and clean. And even when we add new stuff, it works with the old stuff. The store as well, the key value pairs. I'd mentioned we started off with a JSON-based logic, weird thing, not weird thing, it was beautiful, thing in the back end of the store, and we've converted that to JavaScript. We didn't have to actually do many changes because the only things that were exposed inside the clients were a set of key value pairs, values and actions.
Like a little black box.
Yeah.
So the DSL, we've gone into that quite a lot in depth, but it gave us tons of flexibility and it made it easy for other teams to contribute and pick up the project. And it also meant that we didn't have to go and rewrite tons of existing UI code. So that has been a massive help, and I'm glad we did that. Well, I'll talk about this one. So getting the whole team involved, right. So most of the team has now built a component or contributed in some way. So what this does is it helps us spread knowledge around the team. It means that we've not got a single point of failure. And it also means that everyone's an owner. Everyone's sort of on board with the project and everyone feels like they've contributed to make something that, as of now, is really successful. And we're all proud of that. Do you want to go over this one?
Yeah, so bringing the external teams and bringing the other teams in around the business. A lot of companies have structures where they'll have an app developer within a different team. So they'll have web, app, and a few different things in one. Allowing the web developers to contribute to apps gave them a sense of ownership. Really, it helped. If there's a product change, you can do it on everything. There's no kind of barrier there anymore. And it means that we're not scrambling to hire tons and tons of app developers, which is really good and really beneficial.
Yeah, and everything's just sort of being made at the same time now, which is good. We've not got a year-long backlog. There's so much interesting stuff to do. This is a big one as well, because like app development sometimes can get tiring if you're just making screen after screen. So with this, there's so many opportunities to engineer and create exciting technology, and it's given the team to do things that they might not have thought they could do before. Like I never thought I'd be writing on a server like using Spring Boot, but here I am. Now let's talk a bit more about things that we could improve. So a big one.
Yeah, so some app developers only want to do native work. I mean, they've taken a role as an app developer. They want to do everything native, and that's fine. When we were at the mid stage of making this project, there was a lot of stuff that was server only. We were making products on the server, we were making the system on the server. There was a few components that would be native, but it was quite difficult. But as further we've got through this, the more teams that are now working with us externally, the more full our feature set has got. There's actually more time to do the really cool native stuff that people wanted to do in the first place. But there's also the opportunity to do things out of that scope, so you're not just sat building the same native pages all the time. So it's turned out well in the end.
Yeah, we've had to go through that bit of hard work to begin with to allow us a bit more flexibility. So many PRs, PR hell. So suddenly we didn't become just a product team, but we were a platform. And that increased the amount of work coming into our domain, and we had to support it. There was a lot of PRs coming in and a lot of support requests from other teams as well. We've streamlined this a little bit by reducing the PR requirements. Before it used to have to be 2, now we're down to 1. And we place trust in the person that's raised it as well. And, you know, we're always continuing to review how we can improve this and how we can streamline this. So also, how do we test this? Testing has got a bit wild. So we've got multiple client versions to test now, like not just one for Android and iOS, and it's hard to know what's a client issue and what's a server-driven issue on both platforms, because some things still behave slightly differently on each platform. So that means testing's got to be a little bit more robust, and we've got to try and figure out where the issue could be. Jimmy, do you want to go for this?
Yeah, we've got a lot of different technologies now. Obviously, we've got the standard Kotlin and the native clients. We've got the iOS client as well. Spring Boot, Kotlin multi-platform, Kotlin symbol processing, I think we use in a few places. People need to know about stuff like Docker. Loads of different services, loads of different things that people may not have used before. it can be hard to keep up. I mean, I was one of the initial people that started Composable, and I have no clue about half of the stuff that's in it now because loads of people have been adding. There's loads of new stuff that's going on, but that's kind of good. It's good in a way. It's good that there's loads of opportunities for people to have ownership and have expertise in an area that the rest of the team might not do. Especially like if you think about it, if you're just making apps, then how can you be the lead on one specific bit of apps? But if you're making a whole ton of different stuff, there's loads of scope for people.
Yeah, and it means that you can pick and choose what you want to learn as well. And I think that's quite good for junior developers as well that might not know what they want to contribute to. They can have a little play around and find out what it is they're interested in. Do you want to talk about this one?
Yeah, when we initially started off, a lot of people would ask about the performance. In fact, when we do talks, a lot of people do ask about the performance. And the fact is, we've not actually seen that much of a difference. We monitor it, but we follow the rule of optimization is, you don't optimize until you need to. We're watching it. We will improve. We see the payloads going too high or anything. We'll look at that. But yeah, apart from the payload size, it's been fine.
Yeah, I mean, most of the content you've got to be online to use anyway. So you've not lost anything really in terms of online, offline as well.
You can't search while you're offline.
No. You can't support my design. So this is an interesting one because we're still missing some items. So we can't always support the designs that our designers might come up with. And we keep thinking we're near complete, but then more gets added to the design system, which we then have to create in our composable system. So that means that we're always evolving and growing. And I don't think that's ever going to stop because there's always going to be new designs, there'll be new trends, new ideas that people come up with. But there is a massive benefit in platform consistency. And also adding more components and more designs to that just improves the system as well. So it's a blessing and a curse. We're going to talk a bit more now about our actions and future plans. So we've got a few things like richer layout handling, it's like overlaying components, maybe dynamic UI for tablets. We also want to work a bit more on animations, add a bit of flair, make it a bit cute. Advanced action handling as well, maybe interact with subsections or include animations when it comes to that. And we've mentioned Kotlin multi-platform quite a few times. That's already in use, but we're slowly starting to share more code now across platforms and use that a lot more.
Yeah, and with that, it's time to say thank you for joining us on our journey. The journey is over. We've got a few links here. Again, that QR code will take you to all the links in the presentation. Mention at the bottom there, so is anybody in the Manchester area or the north? We've got a JManc unconference coming up soon. 28th of June, we'll be hosting that at Auto Trader. I think, is it on Eventbrite and Meetup? Or? Yeah. Yeah. And what time have we got?
Right, so I think we've got a few minutes left. So if anyone's got questions, we've probably got time for about 2, if anyone's got any. Yeah?
Thanks for the presentation.
Oh, there's a mic there. All good.
Thank you. So thank you for the presentation. Very interesting. I do have one question. You briefly mentioned it about the updates that you need to, by the release process that you do, the pushing of a new version of the app to the stores, etc. I do not know the details, but I do know that there are some regulations about the codes that you push and all that. And when you do, namely something like server-driven UI, you are basically essentially modifying your app at a random point in time without necessarily going through the App Store. So have you had any issues with that? And if you did, how did you manage?
We're standing on the back of giants on this one. Facebook already do it. Airbnb, Spotify, as we've mentioned earlier. I think as long as you don't change any core content and people can still get the same experience, there's not actually that much issue with that. I've not heard of any issues coming back.
Yeah, like it's just using building blocks. If you think of it, we've already added the blocks to our client code and we're just moving them around. We're not really changing too much there because it's stuff that you can already do with the client release that we've given to them. Yeah. Don't know if that answers it. Yeah. Is there any more questions? Yeah.
Thank you for the talk. I have a question about accessibility requirements. Have you thought about that? Because, for example, I'm a native developer, and a lot of things we had to fix, which is supported by native, and now you have to fix it. I wonder how it actually you would approach it with the server-side architectures.
Yeah, I don't know if you've seen, I don't know if it came up on the slide earlier, I'd skip back, but I don't know where it is now. As part of the DSL, we've forced accessibility tags and stuff on it now. Obviously, we didn't start with the accessibility tags. We added them in the future, but because of the way that we have to go through that DSL, developers can't actually make a new component without having a tag on it. So that should mostly be handled. Obviously, it's not perfect. We still need to get more things in there.
Yeah.
But yeah, we're adding and considering that constantly.
Yeah, and the designers at AutoTrader are focusing on that as well. So when you sit down with them to come up with like new screens, that's something they're looking at.
Yeah, all the time.
Does that answer the question? Yeah. Is there any more questions? Yep. Oh, we've got two more here. Oh, and one over the back. Yeah.
How do you deal with offline mode in this kind of server-driven UIs?
So we don't really handle much offline. We never used to anyway in AutoTrader. You need to be able to access the internet to get any of the data back down. And because we never handled that before, we don't really handle that now.
There is still a few things that you can use offline. We've still got, because it's more of a hybrid approach, we've not gone all in and said, right, everything is getting replaced by this new product. You can still view a lot of stuff offline. I think we'll keep that as we're going. We'll probably store the definitions on the client so that, we'll store that response and, let users see adverts or other stuff that they would have seen offline before and still get that same experience.
But yeah, you can't do any like active searches because you wouldn't be able to do that before. Yeah. Yeah. Next question. I think it was at the front here.
Thank you for the talk. How do you manage the user authentication?
Sorry.
The user authentication in the app when the user is logging in?
That's all still done natively. We can fire that we can execute that from the server or do an action to launch that, but that's all still done natively and handled on the back end. The security is, definitely wraps up tight, that one.
Yeah, we've not moved that too much. Yeah.
Again, the hybrid approach is brilliant for that.
I think there was one more question over here. Yeah. Sorry, we've got 3 minutes.
You briefly mentioned that testing is more difficult now because you've got multiple versions that you might have to send to clients. How do you handle that, and how do the testers handle that?
So to begin with, we hired more testers to try and help that process out. But we've streamlined a lot of it because we didn't automate a lot of UI testing before, and we've sort of migrated over to using a lot more automated tools, and also just making sure that when we are developing anything new and when we're adding features, we make sure that the testers are involved in that discussion as well. Like before we kick off a ticket, we'll have a kick-off with the testers involved. Once we finish something, we'll have a kick-out, and we'll tell them exactly what's changed, what they should be expecting as well. And then they'll do a regression test or maybe like use the UI test as well. We've got like integration tests as well.
We've got the snapshots on a component level as well. So in theory, anything that gets sent down to the client should work. It's just the order that it's sent down. So we've got a lot of that. Plus, we just stripped out a load of versions that we supported recently.
Yeah, then we don't need to worry about that. Yeah, I think we've got 2 minutes left, so we'll probably wrap it up there. But we are going to be on the AutoTrader stand down at the bottom, and it's lunchtime now. So if anyone's got any more questions, just come over and talk to us. But thank you for coming.